So class 10 chemistry, today we will start with the industrial preparation of H2SO4, that is the contact process of H2SO4, and also we will see the different consequences for this process, and what are the different peculiarities found in case of this process. So today we will start with the industrial preparation of H2SO4. So today we will start with the manufacture of sulfuric acid by contact process. The steps of industrial preparation of H2SO4 by contact process. If we see, first step actually sulfur or iron pyrites burner. Sulfur or iron pyrites burn in presence of oxygen and produce sulfur dioxide, that is S plus O2 change into SO2, or 4FeS2 plus 11O2 change into 2Fe2O3 plus 8SO2. In second step, that is contact tower at 450 to 500 degree centigrade and 1 to 2 atmosphere pressure. Sulfur dioxide is oxidized by air to sulfur trioxide in presence of catalysts such as vanadium pentoxide. So potassium oxide can be used as a promoter to increase the activity of V2O5 or platinum. So 2SO2 plus O2 change into 2SO3 plus heat. It is an exothermic process as heat energy is liberated. Third step is absorption tower and dilution tank. That absorption tower, SO3 formed in the contact tower, is then absorbed in 98% sulfuric acid to produce pyrosulfuric acid or oleum, that is H2SO4. That is a SO3 plus H2SO4 change into H2SO4. At dilution tank, oleum is diluted using calculated amount of soft water to produce H2SO4 of desired concentration, that is H2SO4 plus H2O change into 2H2SO4. Here also you will see the diagram by which actually this contact process of industrial preparation of sulfuric acid takes place. In diagram also you will see this process. So now move on to the different questions of this preparation. That purified air is required to produce SO2 by burning sulfur or iron pyrites. So in impure air, several unreactive constituents are present which may utilize the supplied heat energy for heating these unreactive constituent along with the desired compound. So to avoid this wastage of energy, purified air is used instead of impure air to produce SO2 by burning sulfur or iron pyrites. Next question is, before entering the contact tower, dust particle and arsenious oxide are removed from the gaseous mixture of sulfur dioxide or oxygen. The contact tower contains the catalyst vanadium pentoxide. If impurities like dust particle and arsenious oxide are not removed from the gaseous mixture of SO2 and O2 before entering the contact tower, then the impurities may act as catalyst poison and reduce the activity of the catalyst. Now move on to the during catalytic oxidation, SO2 to SO3 in contact process, V2O5 catalyst is preferred over platinized asbestos catalyst. Why? So during catalytic oxidation of SO2 to SO3 in contact process, V2O5 is preferred over platinized asbestos as a catalyst, since V2O5 is cheaper than platinized asbestos and less susceptible towards impurities. Next question is, in temperature range between 450 to 500 degree centigrade is suitable for the catalytic oxidation of SO2 to SO3. This reaction shows catalytic oxidation of sulfur dioxide to sulfur trioxide in contact process. If we see the above reaction, that is exothermic in nature, according to this principle, increase in temperature favor the backward reaction. If the temperature become below 450 degree centigrade, it would be difficult to initiate the reaction. Hence a temperature between 450 degree to 500 degree centigrade is most suitable for producing a maximum yield of product by this reaction. So in catalytic oxidation, the contact process 1 to 2 atmosphere pressure is found suitable. Why? Because this principle, if we see here, the higher temperature and higher pressure, the yield of SO2. If we see the like temperature, if the higher pressure, the yield of SO3 increases, but in reality the application of this higher pressure may damage the acid resistant tower and lead pipes used in manufacturing plant. To avoid such damage, a pressure of 1 to 2 atmosphere is most suitable for this reaction. Although sulfur trioxide is anhydride H2SO4, but in contact process SO3 formed is absorbed by concentrated H2SO4 instead of directly using water, because absorption of sulfuric acid in water in exothermic process. So if SO3 is dissolved in water directly, a dense fog of sulfuric acid forms which consist of acid droplet and cannot be condensed easily. To avoid this, SO3 is first dissolved in concentrated H2SO4 to produce oleum, which on dilution with calculated amount of water produces sulfuric acid of desired concentration. So SO3 plus H2SO4 change into H2S2O7. So when it react with H2O, then 2H2SO4. So these are the different consequences of production of sulfuric acid in contact process. So today up to that, next we will start with another topic.